Hey guys, in this video we're going to be talking about correlation. There's three questions that basically talk about just correlation alone. The first one is the one that you can see on your screen with the botanist, and she's collecting aspen leaves and comparing the surface area and the length. There's another one about how long people have stayed at a restaurant based on the number of people that are in the group of their party size or their reservation. And then the last one is the sleep associated, or how sleep is associated with job performance. So those three questions, this is pretty much going to cover section 3.1 in the book. So if you struggled with that chapter, that section, this would be a really helpful video just to kind of watch the full length of, even if you don't have questions on every single one of these questions. So to start with, number 8 says a botanist found a correlation between the length of an aspen leaf and its surface area to be 0.94. Why does the correlation value of 0.94 not necessarily indicate that a linear model is most appropriate to model the relationship between length of an aspen leaf and its surface area? So first of all, correlation is talking about once you draw your least squares regression line. So you've got your data, it's all here on your nice little scatter plot. Then you make your least squares regression line, which is really the line of best fit, but it's more official now. And how good is it at representing the data? So it's a little bit confusing because you would think if our correlation value is high, basically close to 1 or close to -1, then it's doing a good job of representing the data. Yes, that's true, but that doesn't necessarily mean the line is the best way to represent your data. So once, and this is kind of what it says right here, once we have our R value or a correlation coefficient, which is R equals 0.94, then we're gonna, our process is then we're gonna check our residuals plot to see if there's truly random scatter. If we check our residuals plot and there's truly random scatter, then we can finally say, yes, our linear model is appropriate. If we've not done that, we can't necessarily say the linear model is appropriate. Okay, so kind of keep that main concept in mind as we go through these. So letter A says that the value must be exactly 1 or -1 to indicate a linear model is the most appropriate. Definitely not. That's unrealistic, never probably going to happen in the real world. Your line is never going to do a perfect job of explaining every single value, which is when the only time you get a 1 or -1 that's 100% or 100% of your data is represented positive, or 100% of your data is represented with a negative line, a negative slope of your line. So letter A, not true. Letter B says the value must be 0 to indicate linear model. No, again, correlation, if it's 0, that means there's dots all over the place. You've made a line and it doesn't represent your data at all. So again, the closer to 1, positive or negative, your correlation value is, the more data is represented by that line. So letter B, see you later. A causal relationship. So we're gonna stop and pause like always if we see the word cause and be concerned. Should be established before determining the most appropriate model. We don't have to say it's a cause and effect relationship to use correlation, regression lines, and all that good stuff. If we're trying to say cause and effect, we need to make sure it's an experiment, but we don't really have any of that information. So letter C is kind of barking up the wrong tree. Letter D says a value of 0.94 implies that only 88% of the data have a linear relationship. Here's where they're getting that. So 0.94 squared is 0.88, which is 88%. So their math is correct because when you see a computer output model, which I'm going to mess this up, is either in 3.1 or 3.2, that computer output that has all the numbers and you got to read through it and see what's what. Which I think I talk about in the next video, not this one, but that 88%, if we're saying the linear model works, the linear relationship is true, it works, then if we square our correlation coefficient, then 88% is accounted for by that line. So not necessarily an untrue statement, but we still don't know that it really is a linear relationship. So D is close, but not quite, because E is even better. E says with a correlation value of 0.94, it is possible, yes, possible, that the relationship could still be better represented by a non-linear model. Exactly, because again, up here, we said we've got to check that residuals plot. If we've not checked it, then we really don't know that linear is good enough. Okay, so the correct answer for number 8 would be letter E. Okay, our next question we're going to look at is the one about a restaurant manager seeing if the party size, the number of people in a group at a restaurant, affects how long that they stay at the restaurant. So he found that there is, or she found that there is a correlation coefficient of 0.78, which is positive, which means that as the party size increases, so if we have a little graph, then our line would be going positive. As our party size increases, here's the size, I can't write, the time is also going to increase, which really makes sense if we think about going to restaurants with friends and family and all that kind of stuff. So what information does the correlation provide about the relationship between the number of customers in a party at the restaurant and the time elapsed until the party left the restaurant? So keep in mind kind of what we said before in the last, with the last question, just because we have a positive or negative or high or low correlation does not necessarily mean a linear relationship is a good representative. I don't think they talk about linear. So in letter A, it says a relationship is linear. That correlation does not tell us if linear is good or not. So linear, not linear, I don't know based on just the 0.78. That's not what the 0.78 tells me. So A and B are out. Letter C says parties with a large number of customers are associated. Yes, that's a good word. With the longer time elapsed until the party left the restaurant. Yeah, that makes sense because as my size increases, this party size increases, the time increases. So C looks pretty good. Letter D says the parties with a large number of customers are associated with shorter times. Nope, that's not. If it were a negative correlation, yes, D would be true, but it's not. It's not how it's working. Letter E says there's no relationship between the number of customers in a party at a table in the restaurant and the time required until the party left the restaurant. There's some kind of relationship because it's a high number. If we had like a 0.18 or even 0.2 or 0.3, a low correlation, then we can say that there's probably no relationship, but 0.78 is high enough to say that there is some relationship. I don't know if it's linear or not, but there's definitely some kind of relationship. So E is out and C is our correct answer for number 13. Okay, our last question of this video is going to be this last one, or my last one, number 20, probably not your number 20, about an observational study finding the amount of sleep an employee gets each night is associated with job performance. I want to talk about the word association really quick. I can't circle or underline. So association is based on what that correlation coefficient is. So if it's high, we can say that there's an association. If it's low, we can say that there's no association. And by high and low, I mean the higher, the closer you are to 1, positive 1 or negative 1, and there is association. Closer you are to 0, positive or negative, then further you are from having some kind of association. So anyway, the correlation coefficient was found to be 0.86, fairly high. A reader of the study concluded that more sleep causes employees to perform better. Why is such a conclusion not correct? Again, we see that cause and effect word, okay? If we see cause, we know the only time we can claim cause and effect is if we have an experiment with random assignment. This is an observational study. They tell us outright this is an observational study. So we know that cause cannot happen because it's not an experiment. So we know that we've talked about it. I've said it, I feel like 12,000 times, maybe not, but hopefully it's jammed into your head somehow. So letter A says the correlation should equal 1 for a conclusion, for such a conclusion. The correlation coefficient really has nothing to do with whether I can say cause and effect. It's really just the fact that it's not an experiment. So A and B are out. Letter C says the sample was not representative of the population. It may not have been. I really don't know. They don't tell us that information. But again, that's not why we can't say cause and effect. Letter D, causation cannot be determined from an observational study. Yes, 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 all of that. We can only say cause and effect if it's an experiment. Letter D, love it, that's great. Letter E, the correlation value implies that less than 75% of the variability in job performance can be explained by sleep. That's not the right answer, but let me explain what they're saying really quick. They got that 75% because if you take 0.86, which is your correlation value, and you square it, you get 0.7396. A lot of times when you have those computer outputs, which I talked about this in the last question, but if you weren't listening to that one and just came in for this one, those computer outputs are going to give you an R-squared value. Because what R-squared value does is it tells you the percent of variability that goes along, excuse me, with your study, your survey, your whatever, your experiment with what you've done. So this is a true statement. But it doesn't really address the cause issue that they're talking about. So letter E is a great statement, but has nothing to do with what they're trying to get us to look at. So letter D would be the correct answer for number 20. hopefully that's helping you make more sense of these 3 questions. If you've got more questions that I haven't answered, please let me know. Email me, remind message me, let me know. I want to help you out as much as possible before your AP exam.